Okay, so let's start. Hello, welcome. I would like to thank everyone for being here with us this afternoon. It's so nice to see so many familiar faces and some new ones as well. I would like to make everyone aware that this program is being recorded. Welcome to Myron Kayton Science Pub number 23, Mars Rover Curiosity from the Beginning to Now. March is the Red Planet Month, and we will celebrate it with this timely presentation by Adans Ko from the JPL, the Jet Propulsion Laboratory. JPL was founded in 1930, and it's owned by the federal agency NASA and managed by Caltech. JPL's main function is the construction and operation of planetary robotic spacecraft, and it also conducts Earth orbit and astronomy missions. Adans, welcome to the Harvard Club of Southern California. We are very honored to have you share your expertise with us. After your presentation, I will be ready to pack my mini suitcase to move to Mars. That's a joke. No, I am getting ready to go to Mexico, really. My name is Adans Ko, and I'm a board director of the Harvard Club of Southern California and founder of this series. And together with Germán Enciso, our moderator, professor of mathematics at UCI and board director of the Club of Southern California, we coordinate this science series. The series was created for the purpose of candidly dialoguing about STEM-related topics. Therefore, we encourage all of you to write your questions on the chat. Germán, would you like to say something about the format we will follow today?
Thank you, Ethel. Yes, welcome everybody. And we usually have informal questions posted on the chat window. If you have a question in the middle of the talk, if it's something very pressing, we might ask the speaker for a clarification or follow up. Otherwise, most questions will just be read towards the end of the presentation when we have a Q&A session. And if you want to chip in and just ask a question in the microphone at that time, you're welcome to do that as well.
Thank you, Germán. We would also like to thank our affiliate, the MIT Club of Southern California. Thank you, Anu, for your support in making this series so successful. And if you like our programs, please remember to sign in as a member of the Harvard Club of Southern California. Without further delay, let me introduce you to our speaker. Adans is a software systems design engineer and Mars Science Laboratory real-time operations team chief at Jet Propulsion Laboratory. He has served as a command computer flight software engineer and JPL missions operations assurance manager for different NASA missions. Adans specializes in ground data system design and cybersecurity. He's responsible for the multi-mission ground data system tools, which includes mission planning, sequence generation, and SC telecom analysis for current and future JPL missions and the DNS. He received NASA's Exceptional Service Medal for his work on Voyager's onboard computer command subsystem for missions to Uranus and Neptune. Adans has published with other researchers innumerable papers dealing mostly with cyber threat risk assessment of uplink and commanding system of mission operation, risk analysis for non-deterministic mission planning and sequencing, and many more to be named here. Thanks, Adans, for showing your spirit to serve. The floor is yours.
Thank you, everyone. My pleasure to be here, have a chance to share my talk, and hopefully you find it interesting and entertaining because I have a lot of pictures here to show you. And I want to especially thank Ethel. She spent hours of time to work with me and be patient with my schedule. So we are able to be here, and I have a chance to share what I have done on Mars Rover project with you. So thank you again. With that said, I'm going to start with my talk here. So you can see on your screen, I'm going to just show my slide deck while I'm talking. Okay, so we're talking about the Mars programs. Actually, it starts with a Mars rover, a little one called Sojourner or Pathfinders, aka, and it was launched 1997, July 4th, and that was a prototype of the rover, which is, you can see a small cousin of ours. And then that is the next one that landed on Mars as a rover was the Opportunity and Spirit. But one did not survive during the dust storm. And then another one about a year later, also running out of battery. So this in here, we just show one of them. And the bigger one here is the Curiosity rover. Is under the Mars Science Laboratory project. So this is the project that I'm working on right now, and I'm going to continue with the focus of this, but not limited to the rover, because you're going to see a little bit what happened for the Perseverance rovers already on Mars, and the Ingenuity helicopter. So that is the now and beyond part of this talk. For the Curiosity rover, we have 17 cameras on the rover because it helps us to navigate. It helps us to be safe when we're going through the rocks and climbing the hills. And then we have a lot of them trying to give us taking images of the surfaces of the substance. And so you can see 17 of them, and then some backup cameras. And also for the payloads, we have various of the payloads for its purposes. Like there are some of them are really for helping the some of the cameras also are helping for the entry, descent, and landing, so we can capture the information and the atmosphere, so that can be further understanding if we have any anomaly, or helping the future missions how to develop their way to Mars and for their early descents and landings. And then the majority of the payload are talking about they are responsible for during the sensors, knowing the soil, how to break the particles, measuring the radiation, like the X-ray or other atmospheric spectrums, and then also the chemistry compounds. So that is an analysis on board, like a little microwave box. It's called the SAM instrument here. It will take the particles that has done or break or analyzed by other instrument, and then take it inside this SAM, and then itself will do some soil analysis, particles, try to do some chemical changes to the particles, and then do the analysis again. So it's very complex and interesting payloads that put together on the Mars rover, Curiosity rover. And here is the position of the cameras and the payloads that you can see here. So I'm not going to go through this again. Okay, there are 4 goals that we want to achieve by the Curiosity rover since it landed about 10 years ago. So the first one is, everybody talks about it, is, do we have life ever on Mars? So we all know that the building blocks to have life on Earth is carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfide. So our scientists, is based on these ingredients, they look. And the second one is, try to characterize the climate of Mars, because this is important. Because when we go to the final goal, you know why it's important. So environmental understanding, which is vital to understand, is there any microbial life ever on Mars being supported. Okay, the third goal is trying to analyze the geology of Mars. So for example, the layer of the rocks in the craters, and then they will give us history of the past history of Mars, and then that itself will get us a trail of the evidence of water. Yeah, so we'll see some of the picture as example of that later. And finally, with all this understanding and knowing the history, and then we would learn about, is that inhabitable for people? Is that safe for us to send astronaut over on Mars? Is the atmosphere can be tolerate if we have living bodies on Mars? So this is something that is a trajectory that is a NASA Mars program going to do. Now, let me track back a little bit here. In strategically, what NASA does with the planetary mission, usually we have four phases. The first one is called flyby. So we send a spacecraft or satellite going to the planet, and then we just do a flyby. And then it's in a farther distance, but you get picture of the outer planet's atmosphere, and then you try to understand the color, and then you will have the fusion particles measurement and the radiation measurement. So that is the time that you go and study that planet. It is a short time, yeah. And then the second one will be an orbiter. So you will start, because we understand a lot more about the planet, in addition from the telescope. So now you start having a satellite go orbiting, so-called the orbiter of the planet, in months, years, sometimes decades, and just try to take pictures or observe every single piece of the surfaces as possible. Sometimes you have to fly a few from a different orbiting orbital positions. Now the third phase is trying to find something so-called now your surface, that is, you land the lander on the surface. It's a stationary surface. It would not roll over, it would not move. It will stay there to do its very special purpose of job. However, that's the closest you will study on the soil of the planet or surface of the planet. So give you tons of information, what is going on. So the fourth one is the rover. So now you have a movable, drivable car that let you to study more about the surface in distance. So you will have a different objectives, you have a different capabilities that you can make sure you understand the planet. Then we can support the ultimate final one is send a human on the planet, that's what the Mars program, exactly what we are doing. Okay, next. Okay, here's the launch. The launch date on the top here, and then year 2011. And by and large, the spacecraft or the spacecraft setup is in these phases. So in the cruise stage, they will just take all this together. And then once we get launched and separate, it will just fly by itself on the way to Mars. Usually it takes about a year or two, depends on the trajectory, depends on the windows, the time and the position you are between the Earth and other planets and the Mars. You can see the, oops, I moved too fast. So I'm going to a little bit faster now. Okay. And then you will have a descending stage here. So this one, you're going to see something pretty interesting from next slide is, this is the size we call sky crane. You have this very, very doable string. It's like a crane that will take your rover, you descend the part of the rover, and then with the string attached to it, it's like a crane that you put something down. And you have the, this is the rover itself, and then you have the heat shield. And I'm going to show you a picture how does it work. Okay. So let me move that a little bit. So the next picture is about this part here. So you can see the sky crane technology, and then this is how the sky crane being operate, and then this is the rover, how it places the rover after it enter the Mars orbit atmosphere. Then this is how you safely put the rover down. So I'm going to show you a short short video that is what happened when the Curiosity rover was landed. Okay. Thank you for watching this one. I think this is a very fantastic video. It's very by itself. It tells us the journey, which is, I don't know, you guys have ever heard about the word or the phrase 7 minutes of horror. So every time when we try to land something on Mars, the whole mission control room, people kept silent. We don't know what happened. After 7 minutes, we might have the flatline signal. that we did not hear anything which has happened for us before during our journey, for other vehicle landers on Mars. And this one is like a perfect landing. And then also, of course, you heard that Perseverance rover was also a perfect landing using this technology. Yeah. So exciting, huh? I really like this one. Okay, next. Okay, so after the success, President Obama called and congratulate the team and saying, you guys done a good job. And this is really the honor of the NASA's work. And then it is for the American people and the science. So this is where we landed. It's a direction, start going to the location called Mount Sharp on Mars. So we're going to take a little bit of that. But I think the Air Force one looks more habitable than the Rover. Okay. So now this is the self-portrait of the Rover after it's landed. So it's the camera somewhere right there, and then you just take a from one of the angle, it just took a picture by itself. So it's very important to us. It's like a self-checkout. Make sure that we are there, and then look at all different areas. See, obviously, can we spot something that is not looking right? And here's a couple view that from the pictures, and it's fascinating that it just like the rover opened its eyes, and then wow, I saw something. And here's another picture of the portrait. Yeah. Oh, did I? Oh, I'm sorry. This is the, no, that was not other. That was the only portrait that I just showed my fingers. So this is a very beautiful image. That is a panorama image of the Mount Sharp. Remember the landing site, it was pointing very close direction to Mount Sharp, and that's what it is. And then this is the first image of it about a month later that is close enough to take this beautiful one. Yeah. And now talking about our scientists start understanding from a geological point of view, try to understand, is there water on Mars? So you can see this rock having some stream flowing in the history, and the scientists mostly, they can claim, hey, that is some water flow happened before, in the years before the Mars is pretty dry. Yeah. And this is a picture of the drill that is trying to drill on its second rock. We did not, at that time, we did not have any getting drill samples, because we are learning to understand how to drill, and then we want to understand a bit more how the rock substance react to us. Yeah. So it's a very nice picture. And here is another rock that give the scientists a sign of, hey, you have a lot of the iron type of geological rock that give you that property. So that will give you something saying, hey, you have something deal with the water and it can rust. Yeah. And this is the year after. And another beautiful view, panoramic view, that is after we have a 10-kilometer drive on year 2015, but still, this is still early age. Yes, early stage of the Curiosity rover on Mars, and it's still counting. This is a picture after we landed about 2.5 years later. you can see that that is a sandstone on the Mount Sharp. So we stay on Mount Sharp for quite a while. Once that is the site that being studied and clearly looked at by the scientists. And then also that is a lot of things that for us to be trained before we do any more further exploration. Okay, so right here is the first drill sample that we got since 2016. So you can see here, it's just like a very successful drill that we see from where we do our woodwork. So here's the residual, and then some of the material get taken back to the analyzers, and then they will produce some science result and send it down to Earth to our scientists. This is 2018. Unfortunately, driving on Mars is not easy. No one maintained the roads, so you can see them here. So April 26th, we start seeing the tire like this. Lucky that we don't inflate the tire, so we don't have a flat tire. We can still keep going. Now it's 2023, almost, April 2023. So people will say, wow, it looks so bad already. How can you guys want to keep driving? So at this time, we will have the engineer comes in to help. At JPL, we have a place called Mars Yard, which is we put together as close as what we learn about Mars, because we have a lot of data. So we make sure that we would know the rocks around and the position of them and the elevations. They really look as close as possible. Then we have our model, Mars Rover, with us. Then we will have a drive around and then see almost like a simulation. So you will see how the wheel will go up to some rock. It's in such of the property, height, and the angles and all that. So you will try to make sure that we can drive and make the wheels last as much as possible. Yeah, so that's how we carefully drive something that we have by our model, make sure that we will preserve the life on of our rovers on Mars. So that's why we kept going. Yeah. And that's a self-portrait. Actually, this is a pretty famous selfie here, and being taken and then being put on a lot of apparel, mud, and buttons. And one interesting fact is how does this portrait being taken? We want to see selfie like this, right? We do it like this. And then this one is with the camera coming out, and then we'll take 156 pictures of the rover. But then at that time, because of the camera, that just like our arms holding the phone to take the selfie, and then every single picture they have to edit this arm out to make this beautiful selfie here. Yeah. Did I go back? Okay. Here's another picture, bigger picture of showing the wear and tear here. And here is it's a closer picture where we are on the Mount Sharp, and on the in the area called Vera Rubin Ridge, and that was a big deal to us at that time. We decided to drive, or the scientists decided to drive, to take a little bit long drive, to go to another region of Mars to study, because they believe they have different type of geological property they can find by going further to other side. Yeah. Okay. There were dust storm happen on Mars that really wiped out one of the earlier Mars rover. So there's an orbiter called Mars Reconnaissance Orbiter, in short MRO. It took a picture at that time, and then they could see the one of the Mars rover that was sent 10 years ago is right here, and then we cannot see another one. And then Curiosity is still here, so they can see it. So these are the pictures that taken by this orbiter. Yeah. Let me move on before I say something. Okay. And then here is the you can see some dust particles on the Curiosity rover. Yeah. And then here is the area that we have the drill holes here. We've done the drill hole before. And then this is before the dust storm. And this is picture taken after the dust storm. Now I want to get back about this Mars orbiter. They are very important to Mars surface mission. If you guys not heard about yet, that I want to emphasize this point here. So communication is not easy to be direct from Mars to Earth, because now you have something down in the surface, and then your position is not always in view from the Earth. So we have to do something called relay communications. So we have large volume of data that will be sent by the rover periodically. So first it will send to this. So this is a rover on Mars, and this is the orbiter, like a MRO. They will send to the MRO orbiter, and then the orbiter will be a lot easier in view with the space, the ground antennas. So that will send the data back to Earth. And this is not only serve MSL or the Curiosity rover. It serves, I mean, the relay orbiter. Actually, we have more than one that is helping a lot of assets on Mars surface. Yeah. So even for international programs. Yeah. Okay. So let's fast forward to close to today. Last year, end of the last year, we were at the place called Marker Band Valley. This is very recent, and we're still there as of today. And then this picture shows the region of interest that the scientists want to start making decision on where to drill over this region, because they find something interesting to them, which is I don't understand. That no questions on these pictures, please. And this ripple type of properties to them are at the interest. So they may want to go there to target, to drill some holes and give some more data to them, so they can tell us more after their analysis and studies. Okay. Beautiful pictures. This is next two pictures. This looks like a feather. Yes, it's a recent picture that couple months ago taken by Curiosity. Is the light, the cloud across the Mars sky, and it's like a feather. It's very beautiful, right? And this is a first sun ray on Mars. So sometimes you say, wow, we go see Earth. Woo, look at the sun rays. They're so beautiful. And let's compare with what happened, what do we see when we are on Mars surface? Here we go. And it happened this month. Okay. To conclude with the curiosity, before we go to the beyond, here is as of today, this is where we started. 10 years ago, after we landed on Mars, and then the curiosity traveled it. All this area now is right here. We look at the stack here. Sorry. So 3,778. So is 1 day of Mars, and then it's equivalent to 2 hours, 40 minutes of the I'm sorry, 24 hours, 40 minutes of the Earth time. So it's like a 25 hours day. So my bad, my finger, I have to stop it. We drove about 18.51 miles so far. Okay, we have a lot of cousins. After we have cousins before we land, and now we have more cousins in the family. So we have InSight lander, we have Perseverance Rover, or AKA Mars 2020, and then also Ingenuity helicopter, which is coming down from the belly of the Perseverance Rover. Okay, this is a nice, beautiful about the InSight lander. It's really studying the seismologist property of the Mars surface. So you can see a big atometer here that going down to the soil, and it was there for 2 years and getting a lot of data about the soil and the underground activities, the Mars quake activities, we may say. And here's the key days that landed, the launch day, landing day, and then it will stay there for almost like 4 years, a little bit over 4 years. Yeah. And the next one is the one that we just landed on Mars 2 years ago. You can see it's February 2021, and this is a much bigger rover. The purpose of this Perseverance rover is try to collect the Mars geological sample and then put it in a capsule and then place it somewhere that is well planned and picked by the scientists. And later on, that is the larger mission will come and send a sample return, which is you have to land another rover there and pick up the sample by from this capsule, or pick up the capsules, and then have a return vehicle send it back to Earth. So you can see the consequence of the NASA Mars Science Project trajectory. Yeah. So this is itself, and then it will set them aside, getting the rocks and soil set aside on the cache for the future Mars sample return, as I just mentioned earlier. Okay, this is a wonderful picture of the helicopter comes in from where it was mounted on the Perseverance belly, and then it starts separate, have its own life, start flying. So this is a selfie being taken by the rover. Yep, right here. Okay. So what are we trying to do? We have White's brother on Earth, and this is White's brother movements on Mars. So the Ingenuity helicopter, so far it flew 50 times on Mars and never failed. So it really successfully demonstrated a aerial flight on Mars, and hopefully they will enable us to do much better and bigger things. Fun part, I'm going to share some soundtrack with all of you guys. Did you guys hear it okay?
Adans, I couldn't hear it.
Okay, let me. No? Okay.
Yeah.
Just a second.
Recorded on the fourth soul. No.
I shared the link where you can see the sounds.
You mean where you can hear the
You can
sounds?
hear the sounds, right? Sorry.
All right, thank you. Now,
I'm gonna try and play them from my computer.
okay.
Can you hear it?
No.
It's basically, it sounds like.
Sorry, I mute myself all the time. Okay, let me give one more try.
Okay.
Oh yeah, there you go.
Okay, the title says it all. Let me go to the next one. We have more.
Oh, much better.
Yeah, much better now. Okay, let me see. So that is the saps the rock. So you guys can hear that, right?
Yeah, a little bit.
Yes, yes.
Okay. Okay. Let me go to another one. Yeah, this one is even more faint.
No.
Okay. But as you can see from the title, this is supposed to give us the audio of when the helicopter is flying. Let me go to, let me see. That's it. You know what, Ito? I'm going to send you the presentation. If others are interested, maybe you can send it forward to them. They can listen to it on the computer by themselves. How does that sound?
Great. Thank you. Yes, thank you.
That
I
sounds good.
hope.
Sounds good. And also, I as I mentioned, I just share the link where anybody can click on that link and then download the sounds also and directly from that website.
Wonderful. Thank you.
Thank you, Herman.
Okay, as I mentioned that the Mars 2020, the Perseverance is trying to put some of the soil and rock samples on the capsule. And here is the capsule. And then this picture actually shows 10 of them. But I want to zoom in one that easier to spot on this slide here. So you can see this. And later on, when we have a mission called Mars sample return, right here, it will pick up those capsules and send it back to Earth. Now, this is still, of course, is an artist concept, how this look like. And the sample will be picked up either by a rover, a mini rover rolling and then come back and position them here, or by the Ingenuity helicopter, or should be bigger one because they need to do some more heavy lifting work. So that's all I have prepared to share with you guys. Thank you very much.
All right. Thank you, Adams, very much for your presentation.
You're welcome.
We do have a few questions. And Dan Sherkoff asked a question first about the design of the rover and whether and which one comes first, whether the mechanical object of the rover comes first or the software to operate it comes first.
Actually, that's not really my question to answer. I don't have that knowledge. Which one comes first? And I know they were very important. And also, okay, first, my focus is on the software and also the ground data system software, which is the software that use on the ground, and the focus on that design, the system that I deliver is something like you see in movie. You will see them in a mission control, and then they try to use a lot of software and equipment to communicate and to control and plan the spacecraft activities. That's or talk to from the ground, talk to the spacecraft. That's my training. But now, but still, I want to share some of my thoughts about this question. Is from the very beginning, if we have the ones, we never done anything for that project. Like this is something that we first would do for Mars. Then we would have people comes in, maybe will be more distinctly make the decision which part first, hardware or software. Yeah. But now since Curiosity is already the third generation of the rover, we have the Sojourner, which is the Pathfinder prototype one, and then we have the Spirit and Opportunity, then we have the Curiosity. As a matter of fact, when I first started working on the Mars projects, it was the for the Opportunity and the Spirit rovers. So we understand the blueprint, we understand what we need to do, both hardware, flight software, ground software. So we have to learn from them and then inherit a lot of important components and design from them. First is the reliability, and including learning from with a lot of lessons learned, but learning from mistakes, and also that we know things are working before. Yeah, so usually you have a lot of inheritance, and in result we get a better design. Yeah, it's a little bit more conservative, but this is a big investment from NASA, so that will save money and time to develop them, and then we can just keep adding things more extensive, more capable, or when we are doing much when we are keep doing the Mars explorations. And the software, the flight and ground, we are doing it at the same time now. But for the importance and the priorities for the project, definitely is first, it's the hardware, because you want to make sure the hardware is working. You want to make sure the one that before they put on the flight software there, you want to make sure we flesh out enough reliability and defect before you go and try to run your flight software, test them, flush out the problem, and then ground software will come in the middle. And because you have to run your ground software to interact with a stabilized, pretty reliable, understandable flight software interaction, then to test the ground. And the ground, of course, that is the most component pieces, is the human use of your ground software. Then they come in to the very last to test the software and test the ops scenario to train them. Yeah, I hope that gives you a long answer to your question.
Sounds good. Thank you. Yeah, that was very, very, very precise. So Fred Coons asks a question about colors in the photos that you sent. He's wondering how the colors are verified for accuracy. How do you know that the colors we see are the actual colors on Mars?
What I learned from the project, the data processing, the imaging processing experts, and also the scientists, they try to put the color in for two purposes. One is what is the reality of the Mars color, like they know the material that is the what they see, the material should be darker this way or lighter that way, or they are using infrared or whatever instrument. Then they put together this image, and also they want to put the color that is fit into the human eyes visible on Earth. That I heard is also the ingredients to help them to make decision how to adjust the color. Now,
but wait a second. So the pictures that we've seen here, are they mostly black and white that have been colored afterwards?
yes, mostly they're black and white, and then they come back and they use the they will analyze them and understand the logic behind it, which is those are the stuff that I heard. But then the algorithm, all the knowledge behind it, I don't have that. Yeah, my apologies.
But what is the advantage of doing this black and white versus just taking them in color like you would with an iPhone? I mean, is that?
You mean why we just studying in black and white?
I mean, yeah, why not take the picture in Mars on the spot in color?
We will have the color again. I don't think I should answer this question in too much detail because I don't have that knowledge again. I saw the infrared color, and I saw a lot of raw images of black and white. That's what I will see.
I see. So if the picture is using infrared spectrum, then that makes sense. I mean, it's by definition, it's not the colors we're used to seeing, right? So you have to color them separately.
Yes.
That makes sense. So
I can get your question back and then someone to.
It's okay. So Armin is asking, how are locations named, such as the Vera Rubin Bridge that you mentioned? What did Vera Rubin do to get her name on that bridge?
I think it's just like why I would, why Tesla calls its car Tesla, right? I think it's the scientist community, they think, or the people vote by people or vote by the science community or students. They try to recognize that person or that event.
Okay. Another question: is it possible to update the software of a rover from Earth? Can you do this remotely?
Oh yeah, good, timely questions. We redesigned our software in the past 5 years. In April, next month, we're going to upload, well, actually, be accurate. We already upload the new version of the software on the rover, and then next month we're going to swap it. Yeah, so next month we have a pretty critical event that we are going to do. Yes, but however, the rover is still working in parallel. It's not like we are putting anything in jeopardy. It's just that switch that we can do, and then if it's not happening, we just switch back. It's like a pointer. But
I see.
short, yes, we are doing it.
Sounds good. Another question: Alan Schumann is asking about the time, between to get a signal all the way from Mars and Earth, and the time lag for controlling the rover. If you do it from Earth, you can do it. You have a human person controlling, but it takes a while for the signal to get. And if you do it remotely from Mars, you don't have anybody who's able to control it. He's wondering if there is a hybrid control system so that local automated controls handle immediate needs, while Earth-based controls handle less urgent issues.
Okay, let me see if I use my experience, but different terminology, I can understand these questions. The first ingredient that to this question is when the light time travel. So from Earth to Mars is about 8 to 10 minutes, and then round trip light time we talk about the ballpark of 20 minutes. So that is a latency. So you cannot really have a instantaneously control, real-time control. You type something, just like when we're talking here, you and I, we talk like almost like no delay. So for the Earth, when we try to do something with the rover, we have to put a plan, so-called a sequence together. So you will plan like a day or two. Usually we have a day of the soul, day of the Mars life for the rover, or two, depends on the availability of the deep space network antennas for us to communicate. So you put it on the rover, and the rover will work accordingly. Of course, you have to validate all your plan, make sure it's passing all the rules. You use the your resources not going to oversubscribe, and especially the critical resources like energy, and your communications not put you in out of field, because otherwise you cannot communicate. Don't shut down some of the equipment, and don't do something that two events together that way violating something, make your spacecraft in danger. So all that being checked, then you send that sequence, and then the rover will execute accordingly. Now, but what happened? That's once it got there, out of luck, you are there by yourself. The rover will just, it's a robot. You tell them what to do, but then if it's glitches, that there's a mistake of the model, or the hardware might have problem, then the face-off itself, the design is you have this so-called the anomaly handling protection. So when it's a state or something went wrong, either hardware, software, or skipping some sequences, in return, the spacecraft turns into a different state, even though it's benign, but it changed it, not per predict. That's very important to us. Each step, if it's not per predict, that we have to deal with it. Care, very, very carefully. So the spacecraft will put in a state, depends on the severity of the unexpected event, and then it will have some signal coming back to the ground. Not high volume, because we want to send a piece of information to us quick and precise. So we got that, we decipher it, and then we have a lot of responses ready. The subject matter experts together, and then we'll analyze it, put the solution, and then we configure, or we send something to fix it. Yeah.
Sounds good. And then I guess to one final question is, since the goal of perhaps one of the main goals of these rovers is to tell about the presence of life in Mars or the previous life in Mars, what can you tell us about the results so far? Have they been, I mean, I understand you don't have any smoking gun, of course, but the preliminary evidence, does it make you think that perhaps there was life on Mars at some point?
Well, what I saw and I heard, things are being published. We find water, definitely. There's a history of water. There's, I think the science community accept that. And there is methane gas, because it's not only the rover find it, also the European Mars Express orbiter sees it. But then now, even though you see those ingredients and that kind of properties, a lot of time they cannot draw some further conclusion is the behavior of that property. So the community itself will have a lot of different way to look at it, and depends on the data, depends on the expertise. So that itself, I think, will take longer time for us to draw a simple answer to this. Can this water drinkable by Earth-like, by the Earth-like life?
Mm-hmm. I see. All right. There's more questions, but I think in the spirit of time, since we already ran over, I think we're gonna finish, wrap it up and finish. I want to thank everybody again for coming. Thank you, Adans, for agreeing to come. It's great to be able to talk with you directly. You work on this every day, straight from the horse's mouth. And I wish everybody a great rest of your weekend.
Thank you so much again. Thank you, everyone.
Thank you, guys. Thank you so much.
I'll talk to you later. I'll send my presentation to Ethel, and then I hope to see you guys next round.
Thank you.
Okay, bye-bye.
Bye, everybody.